Okay, so this was this section from R1 and R2. R1 being the distance formula to classify the triangle. This triangle had the side lengths of root 41, root 65, and 3 root 2. If you're asked to use distance formula, make sure you are simplifying your square roots like 3 root 2. And then to classify that, that would be none of those above. Okay? If it's right, I'm looking for a squared plus b squared equals c squared. In that case, I got like 59, which does not equal 65. And then no two sides were the same, which meant no isosceles or equilateral. Questions on 1? Okay. Number 2 was your diameter, and so I found the center being 1, 1, and the radius squared was 13. When you plug it back into the equation, make sure it stays squared. So some people wrote like r equals the square root of 13. That is what radius is, but remember your equation is r squared, which means it should have been just 13. And then 3, the intercepts were -5, 0, 0, 5, and 0, -1. And then it was not symmetric to the x-axis, the y-axis, or the origin. Anybody have any questions on any of that so far? Anybody still coming down? Okay. And then came the piecewise function. So graphing the function. So I'll be honest, I usually, like if it's a combination of a line and a parabola, I will do the line like by hand drawing it. So I went up to 3, and then you can go up one and right one or down one and left one, and then erase the part you don't want. You're going to have a pencil tomorrow and an eraser, so you can do it easily. And then for the parabola, if it's something you're not knowing exact points on, then you want to plot the points. So that's what's happening up here. Okay, I took the points from within this range. So starting at -1, and then greater than would be 0 and then 1. I plugged those points in, and I got the beginning of my curve. Because this one was greater than, that's why this is a solid dot, and then this one was greater than, this one is greater than or equal to, which is why that first one's a solid dot, and then this one is greater than not equal to, which is why that little one there is an open dot. If they were both solid dots, it would fail my function line test, right? My vertical line test. So you need to make sure that it passes it. If you graph your piecewise function and it fails your vertical line test, you did something wrong. These are functions, so make sure that they pass those function rules. To evaluate, you kind of have two options. If it's on your graph, you can use your graph. And if it's not, then you can use your equations. Questions on those? The first even one, 48. The direction said, find the domain of the function. So domain is all real numbers with the exception of what 3 cases? A variable in the denominator? Under square root? Good, combination of the two. So this one has a variable in the denominator, but if I set this not equal to 0, and I solve it, I get x squared cannot equal -1. And when I go to square root that, what happens? There's no such thing, right? So this is when there'd be no restriction. There is no number that you can plug into x, then square it, add it to 1, and have it be a 0. So this would be -infinity to +infinity. All numbers work there. Essie.
So for number 15, the review, it doesn't want x squared, so x minus 16.
Oh, it does?
Yeah.
Oh, okay. I'm gonna work out the x squared. Okay. So we'll talk about the difference, but I'm gonna work out the x squared too.
Would you ever get no solution? Or no?
It won't be no solution. So the no restriction is your -infinity to +infinity. There should never be one that nothing works.
Right.
Yeah. All right. So 50 as it is x squared minus 16. So this has to be greater than or equal to 0, and then this is where we've got the quadratic mixed with the inequality, right? So we would solve it as though it was. Square root it. As though it was an equals, and I get plus or minus 4, but then I set up my number line, so -4 and +4, and I plug in numbers from each range. So something less than -4 would be like -5. If I plug that into here, or into, yeah, I would get -5 squared minus 16 is supposed to be greater than or equal to 0. 25 minus 16, that is 9 is greater than or equal to 0. So this section works. Then I would plug in something from within here, like 0. 0 squared minus 16 is -16. That does not work. And then plug in something from the right here, like +5. +5 squared minus 16 would be 25 minus 16. And again, I get 9 greater than or equal to 0. And that section works as well. So because this is a greater than or equal to, what kind of brackets or parentheses go on the -4? Brackets. So it's like this and like this. So my domain goes -infinity to -4, union 4 to +infinity. I see. Oh, sorry, Cindy. If it was in the denominator, it would be greater than. So the square root itself can be 0, right? Because you can square root 0. But if it was 1 over that, that's when it would be greater than and not greater than or equal to. No. So we're saying, see, wait, 0 you mean? Yeah, so if I plug in 0, I'd get 0 squared minus 16, which would be negative. That's why we rule out this section. That section's not part of our answer. Yep.
So anytime you, just to make sure, anytime you have a greater than or equal to and you have a square and you get the square root, you have to do this.
Yep. Yep. Anytime there's an inequality mixed with a quadratic, that's what's happening there. Okay. So the other way, the way that it was written on your review, just says this, right? So then this just has to be greater than or equal to 0. X has to be greater than or equal to 16. Bracket on 16 to +infinity.
So on the test, are you going to tell us when we need to write interval notation, or is it going to be always?
It's always interval notation. Okay. Yep.
But sometimes the book or calc chat, at least
when we started it, and then we went, like I said, we're going to slow roll into it, and then once we get into it, you're going to need to know how to do it always. So that's interval notation. Your increasing, decreasing is interval notation. Anything that's greater than or equal to 0, like f of x being greater than or equal to 0 based on your graph, was interval notation. Okay, the next even was your difference quotient. So remember that you need to memorize that this is your difference quotient, f of x plus h minus f of x all over h. So the first thing I'm going to do is take x plus h and plug it in to both x's there. So x plus h squared minus 3 times x plus h plus 5. We've done this so many times that you may already know that this is x squared plus 2xh plus h squared. If you don't, then you're going to have to FOIL that out. Minus 3x minus 3h plus 5. And then I would see if I could cancel anything out from here. There's only 1x squared. There's only 1xh. There's only 1h squared. There's only 1x, 1h, and the constant. So it stays how it is. That's the first part. That's this part here. Then from that, I'm going to subtract the whole f of x. So x squared minus 3x plus 5. This negative goes to each term. So now I've got x squared plus 2xh plus h squared minus 3x minus 3h plus 5 minus x squared plus 3x minus 5. Once you do that step, you should be able to cancel things out. So I've got a positive x squared and a negative x squared, a negative 3x and a positive 3x, a positive 5 and a negative 5. And I'm here. All of it goes over h at the end. And then all the terms have h. And I end up with that. Questions on that one? So there's another difference quotient there. I would highly recommend you work it out if you haven't already, especially because that one has a number on the front. So after you FOIL this part out, if there was a number here, you would then have to distribute that to each term. Okay. There's just a lot of steps that can be done carelessly, and the mistakes get made that don't need to get made. So make sure you're very careful with this. Questions? And the more comfortable you are with that process, the faster it's going to go. Okay, so did it look like this?
Yeah, I don't know. No, I was confused.
No, actually it should be fine still. You have it in parentheses. I graphed it on this, but like on your, I'll show you. On a graphing calculator, it looks like this, and it looks like it almost doesn't touch there. If you look at your table, you'll see that it does touch there, okay? Or if you think about those zeros, right? Because you could find the zeros. If you would set that equal to 0, then it's going to be a positive and negative 6. So your domain goes from negative 6 to positive 6 because it's left to right, and your range goes from 0 to the max there, which is what, 1, 2, 3, 4, 5, 6, right? Yeah, 6. So I would just make sure you know how to find your domain algebraically. If you solve that for 0, I mean, it has to be greater than or equal to 0. That's how you would set up your number line. And then the range only comes from any kind of like a max value that comes out of there, should you have that domain. As long as you can do your domain algebraically, you're fine. Yeah. So I would know that this is, because you could get that question on either parts. You could either get it on a part in which you have to graph it, like on Thursday's part, graph it using your graphing calculator, answer questions based on it. Like I could have to find the max from there. I could have to find increasing and decreasing from there. Even and odd, this one would be even, right, if I fold it along the y-axis. But you might also get just this question on the algebraic find domain. And that's where you have to set up your number line and do your test points, because you've got that 36 minus x squared would have to be greater than or equal to 0. And then you'd end up with your test points, negative 6 and positive 6. And then plug in your values. Anything left of negative 6 is going to be too big. Anything right of negative 6, I mean, yeah, because it would end up being 36 minus, let's say, 49. Anything to the right is not going to work, which is why you get that same set that would match your graph. So I would say make sure you can do them independently. Make sure you can find the domain of these functions algebraically, and then make sure you can find domain and range, increasing, decreasing, zeros, all that stuff using a graphing calculator, because you could see them on both. And then that's the 59 is the only one that's not transformations. The rest of them are transformations, so make sure you could also graph those.
So when you have to do the what's it called, the number line one,
Yeah.
you just plug it back into the original.
Into once you, the original inequality, yep. You know how to find it. Find the inverse. Y equals 1/2 x plus 3. Switch, right? Subtract the 3. Multiply by 2. And then the last step is f negative 1 of x. So this is your inverse. That's the first part. Find your inverse, right? Then it said verify that f of f negative 1 of x equals x and f negative 1 of f of x equals x. So this was like the very first example that we did with inverses. We said if two functions are inverses of each other, then if I take f of f negative 1 of x and simplify it, I should get x. And if I take f negative 1 of f of x and simplify it, I should get x. So for the first one, I'm taking this and I'm plugging it into that x. So 1/2 times 2x minus 6 plus 3, and I get x minus 3 plus 3, and I get just x. So that's 1/2 of the verification. Then I have to do the other way around. I have to take f of x and plug it into f negative 1 of x. So 2 times 1/2 x plus 3 minus 6. Distribute. 2 times 1/2 is x plus 6 minus 6 cancels, and I get just x. So the verifying is plugging one into the other for both. So you have to do f of f negative 1, simplified, it should give you x, and then f negative 1 of f, simplified, it should give you x. That's how you check to make sure or prove that two functions are the inverses. So if it said verify, that's what you need to do. If it said find it, you're just finding it. All right, and then the last even is 132, which says use a graphing utility to graph the function. Use the horizontal line test to determine whether the function is one-to-one and an inverse function exists. I can actually graph this by hand because this, hopefully we know. That's a parabola, right? 132 is a parabola that is shifted in which direction? To the right one. So my point would look like this. Does this pass my horizontal line test? No. So this would be not one-to-one. And it does not have an inverse. So you will see like these put together, figure out if it is, not using a graphing calculator, but figuring out if it is one-to-one based on its equation, and if it is, then find the inverse. If it's not, then you'd say it's not one-to-one. You don't have to find the inverse.
For inverse, we just switch the x and y,
Mm-hmm.
and then find
Solve for the new y, and then at the end, put an f-1
and then
back in for the y.
Oh.
Yep, which is like 135, 137, 139. Any questions up to that point? All right, so we're going to graph this from start to finish. So if I got this, and this would be on Thursday's portion of your test, okay? We're going to get f of x, which is x to the third. So I do x, raise my little caret to the third. Come out of your exponent by hitting the arrow over. Be careful you don't stay in that exponent. Minus x to the second. Again, you can come out of it by arrowing over. Minus, oops, that's a plus. Minus 9x plus 9. Hit enter, hit graph. And actually, I'm going to adjust my window. So the first time I did this, my window, because it's going to be different depending on what you're looking at, I would say that this would have been my standard window, negative 10 to 10 on both axes. So what happens when I do this is I've caught my min, right? But I'm not catching the max. Does everybody see that? Yes? So I'm going to adjust. I can either zoom out, which it gets really far out. That's kind of hard to read. Or I can adjust the window. So if I adjust the window, I just need my Y max to go higher. So even if I went to, let's say it's 15, and graph it and see if I can catch the max, still not there. So I go back to the window and say, okay, I need it to be higher. Let me change that. Maybe I'll go to 20. And I graph it. And now I catch my max and I catch my min. Everybody with me so far? Make sure you know how to adjust that window, because you might get some graph that you don't know where the top is if you cut it off, okay, or the bottom. Make sure you know how to adjust it. I would tell you put it negative 10, 10, negative 10, 10 to start with, but you might not get something that falls within that range. So you want to make sure you know how to adjust it, okay? So that's the first thing. So when I look at this graph and it asks you for domain and range, what's happening from my left to my right? What would your domain be? Negative infinity to positive infinity. My arrows are pointing left and they're pointing right, right? The graph being cut off implies that that is going up and down. Those are arrows, which means my range is also negative infinity to positive infinity. Questions so far? Okay, so now, oh, it's gone. I have to find an increasing, decreasing behavior, 0, relative max, min, and determine if it's even, odd, or neither. So if I know this is increasing, and I know this is decreasing, and I know this is increasing again, I at least know those intervals, but I can't find exact points from this graph. So my advice is find your max and mins first. So if I do that, okay, to find my max and min, I go to second trace, which is my calc menu. And let's say I want to find my max first. So I go to maximum. It's asking me to find the left bound of my max. So because my max is here, I need to put my little dot somewhere to the left of it and then obviously somewhere to the right of it. So I'm going to go left on my graph until I pass it. It doesn't matter how far past I get as long as I pass the max on the left. I hit enter. Then it says, where's the right bound? So I go right of it. Again, it doesn't even have to be the same distance. I can go really high on one side, really low on the other. It doesn't matter. As long as I am left and right of it. And then it's asking me, do you want me to guess? Yes, I'm ready for you to guess. Hit enter. And it takes you directly to that maximum point. So I'm going to write my max at, and it's going to say rounded. I think it says round to 1 decimal place. Just pay attention to the directions on the test. But this would be negative 1.4 and positive 16.9. Are we good on max? Yes? Now I need to do the same thing for my min. So second trace gets me back to my calc menu. I now want my minimum, which is 3. This time I got to go left of my minimum, so I'm scrolling down. I actually could have put it all the way at the top. Doesn't matter, as long as it's left of it. And then come past it, go right of it, guess, yes, hit enter. And my min is 2.1 and negative 5.0. Still good? Yes? Okay, while I'm here, so before I do increase and decreasing, I'm going to do my zeros. So I'm going to go second, trace back to my calc menu, and find the zeros. So I go to 0, and it's saying, where's the left bound? How many times does this graph cross my x-axis? 3 times. So I'm going to do this 3 times. I'm going to go first to the first one, which is about here. Left bound means it's to the left of that, which it is. Right bound to the right of it. There it is. Guess. Yep. And that's negative 3, 0. So the first one's at negative 3. Zeros we list, okay, because they're the x values. Then I do it again. Second, trace, go to the 0. I want to go to the second one, which means I want to come past this one. Somewhere over here, even that is left bound. Go past it. Now it's right bound. Guess, yep. Bring me right there, and it's at 1. And then it happens one more time. So second, trace, go to 0. I am left of it. I'm right of it. Ready for me to guess? Yes, it's at 3. So these were all whole numbers. I actually could have gotten these from my table values, okay? They will not always be whole numbers. You could even get this from factoring. But they won't always be that case. So make sure that you can find them from your graph the way we just did. Questions so far? Okay. Okay, so I just took a picture of it so that we can go back to increasing and decreasing behavior. So I know that it is increasing from this point to this point, okay, which would be what range in interval notation? Negative infinity up to that first x, which we identified in our max value, right? The first x is what? This point we said was negative 1.4 and 16.9. That's why we need that point, right? So where does it stop increasing? That's your y. So you want to do your x, right? Which is negative 1.4. This is increasing, okay? Then it changes direction. It goes down, which means it is now decreasing. And it is decreasing from negative 1.4. And when does it stop? This is our second point that we got, which is 2.1 and negative 5.0. So it stops decreasing at what point? 2.1. And then it changes direction again and goes back to increasing from here to here, which is what? 2.1 to positive infinity. So my advice is do it in the order that we just did. Get your max and min points so you know those exact changes. You're going to actually draw, like hand draw, a little graph for me so that I know if your answers are wrong. Did you base it on the graph but read it wrong, or did you base it on a wrong graph? Let's just say, and I'm sure it won't happen because you're all super smart and you're going to be really, really careful, but let's just say, hypothetically speaking, you graph your actual graph wrong on your graphing calculator. Now you have answered domain and range wrong, max and min wrong, even and odd, all those questions wrong based on a wrong graph, okay? Instead of earning no points for that section, because that would be devastating, if you show me a graph and the graph is wrong, but you answer the questions correctly based on your wrong graph, does that make sense? I'll at least get to give you back some partial credit, okay? So that's why I'll give you a little space so you can actually draw your graph. So you want to identify like your max points, your min points, that kind of stuff right on that graph. It'll make it easier for you to identify increasing and decreasing. All right, so then we did the zeros, we did the max and min. The only other thing left is even and odd. So what am I looking for? How do I know if it's even? Symmetric to the y-axis. Is this graph, can I fold this over at the y-axis and have it overlap? Nope. So it's not symmetric to the y-axis. Okay. How do I know if it's odd? Symmetric to the origin, right? So can I fold this top and bottom and left to right, or along either my y equals x or my x equals y line and have it overlap? No. Okay. Which means that this is neither. Okay. Let's say that we are not comfortable with that stuff just yet. What's the other way that we can answer those questions? If not from the graph, then by doing your tests for symmetry, right? I'm going to group those. There we go. So from the graphs, we're saying it's neither. But if you couldn't figure that out, then to test for even, I would change the x to negative x. So I get y equals negative x to the third minus negative x squared minus 9 times negative x plus 9. This becomes negative x to the third minus a positive x squared plus 9x plus 9 would equal y. It did not go back to the original, right? We see that. And does every term change? No, only the x to the third and the 9x values change. Nothing else changed. So that's why it's not even. And then if I want to do odd, the left side only becomes a negative y, and then everything on the right would already be changed. Because I would have plugged in a negative x and a negative y. Does not go back to the original, okay? And again, only some of the signs have changed and not all of it. And that's why this would be neither even nor odd. So quick and easy is from your graph, but if you are unsure or you want to double check, then the second way to check it is based on your negative x plugged in for the even, negative x and negative y plugged in for the odd. Questions on any of that? Okay, so all the odds are worked out in Calc Chat. Remember, the link to Calc Chat is on the home page, as is the name of your book. So when you do that little pull down menu, it should be Pre-Calculus with Limits, AGA for a Graphing Approach, the 6th edition. But it says it literally underneath the link to Calc Chat if you can't find it. Okay, if you haven't found it yet. But all the odds are worked out there. Ignore the sound in the background. Yeah. Okay, so again, so I would say that, again, you can approach this two different ways. I'm going to do one way and one the other way, but I tend to mix them. So if I'm going to take this one first, let's say I'm going to say that that is y equals x plus 3. That's a line, so that's usually pretty easy to graph. So I'm going to go up to positive 3, and I'm going to go up 1 and over 1 or down 1 and over 1 in either direction until I form myself a line. And then I'm going to look at the restriction here, which in this case says that it's only good for the values that are less than or equal to negative 1, which means I'm only going from this point and left. So here, 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 and down in that direction. So then I'm going to come back over, and you'll have a pencil, so it's different from Notability. You'll erase the part that you don't want, okay? And that point gets a solid dot because it's or equal to here, right? Less than or equal to. That means that it's going to get the solid point. So then when I go to do the second part of the graph, so let me change the color. Okay, let's say it's y equals x squared minus 1. This is a parabola shifted down 1, so I know that one. I know that much about it. But you may not get exact points. Like I know that at least this is an exact point, but I don't know the other exact points necessarily. So that's when I would do the second method, which is plug in points. So I'm going to plug in values for x and figure out what the y is. I start at the one that they give me for the change of the range. So I'm going to start at negative 1, and then because it's greater than, I'm going to the right of negative 1, so then I'm going to plug in 0 and I'm going to plug in 1. So if I plug in negative 1, I get negative 1 squared minus 1, 1 minus 1, which is 0. We know what happens at 0. 0 minus 1 is negative 1. And then if I plug in positive 1, 1 squared minus 1 is 1 minus 1, which is 0. So now when I graph, I'm much more precise, except that I know that that one is a solid open dot, this is a solid dot, and it's going to continue to the right. That open dot happens because this is not or equal to, it is greater than. If you had made it a solid dot, this would fail your vertical line test, making it not a function. And this is a function. A piecewise function is still a function. So it's got to be able to pass your vertical line test anyways.
That's what the open dot is.
Yep, has to be there. Yep.
Can we just like, so to figure it out if it's a function, multiple x's can't have the same x's can't have a different y.
Correct.
And then if I'm like 1 to 1 to have an inverse, it's
Same y can't repeat with a different x. Yep. So for function, right, function, there's 3 ways. One is by points. For points, x can't repeat with a different y. So something like 1, 2, 3, 4, 1, -2, that would be a no for a function. The second way is by equation. And this is when y can't be raised to an even power. Or y can't be an absolute value. Okay, this would turn it to a parabola on its side. This would turn it to a v on its side. So those would be no. And the third way is by graph, which is the vertical line test. If I could spell vertical, that would be good today. Vertical line test. Which both of these would fail your vertical line test. And then that's function. Then later came, is the function 1 to 1, which means it would have an inverse. Same 3 test points, equation, and graph. For the points, now the y can't repeat with a different x. For the equation, now the x can't be raised to an even power or be an absolute value. This would be a parabola. This would be a v, which leads to the test, which is the horizontal line test. So it wouldn't be a function. If it's 1 to 1, it's already saying there. Well, we've seen 2 examples though. We've seen, here's an equation. 1, identify if it's a function. If it's a function, is it 1 to 1? If it's 1 to 1, find the inverse. So that was that one kind of question, right? The others are identify if the function is 1 to 1. So you're already saying it's a function. It should have already passed your function test. Now you're looking to see if it's 1 to 1 so that you can find the inverse. But you could see a part where it gives you, like if it has f of x already in it, it's telling you it's a function. You're only testing for inverse. But you could see where it just says y equals this, and you're testing to see, is it a function first? If it is a function, is it 1 to 1? And if it is, find the inverse. You're welcome. Esty.
Can you do number 59?
Okay, so this is the last one? Is that what you said? This is the last one from the homework from 1.6. It said use the graph of the function f to complete the table. So you want to identify the points like on from your graph. So if x is -3, which is here, what is the y? And it looks like the y is 4. And then -2, the x is -2. The y is here, which is, oh, but that's, I want to do this. First do this. So these values of -4, 6, -1, 0, 1, -2, and 4, -3 are your initial x and y's. This is now saying, well, if that's the x, what would be your f -1? So you want to take and flip those point values. So you would say that the x's become the y's and the y's become the x's. So if x is -3, that's this point because it's flipped. -3 would go with 4. -2 would go with 1. 0 would go with -1. And 6 would go with -4. So all you're doing is taking your x and y's from your initial function and then flipping the order. so that the x becomes the f of x, which is the same thing as your y. And the y becomes the x. Does that make sense? Okay. Any other questions from this 1-6 homework? Vicky?
It was determined algebraically whether the function is equal to 1, so f of x equals
X minus 7 underneath the square root?
Yeah.
Okay, so this x is not in absolute value, and it's not raised to an even power. So this is 1-to-1 and would have an inverse.
Right, so then it asks you to find
Okay.
greater than or equal to 0.
Okay, so if the inverse is, right, because this is, watch what's going to happen, right? So I get y equals square root of x minus 7. Switch it. X equals square root of y minus 7. To get rid of the square root, I've got to square it. And I get y minus 7. And then I have to add the 7. And then the very last step is plug that negative f negative 1 of x in for y. So the reason why the greater than or equal to 0 is there is because this function itself is a parabola that's up 1, 2, 3, 4, 5, 6, 7, right? This would fail my horizontal line test, which means it wouldn't have an inverse, except that it's telling you that it's only for the values of x that are greater than or equal to 0. That's why the restriction's there. Does that make sense? This is your, and it would have to be to that, to restrict it so that it did have an inverse. Okay. Amber. So everybody overcomplicated this. I'll be very honest, okay? Because if you look at what the answers, like if you go back and you look, you would have been like, are you kidding me? When you add f plus g, literally all you have to do is x squared, square root of x squared minus 25 plus x squared over x squared plus 1. And then nothing can get simplified. So you literally could have left it like that. Some people went through the work of finding a least common denominator, multiplying it top and bottom, which also is correct, but you didn't need to do that. There's nothing to combine there, which means it literally would stay that way. Yep. Except for, so then the minus, right, is the minus x squared over x squared plus 1. So it would have stayed like that. The multiplication, you could have actually just done like in the denominator. Oh, it'll catch up. If it's f over g, then it was the square root of x squared minus 25 over x squared plus 1. This is a fraction within a fraction, complex fraction, so you had to do keep, change, flip. So I keep this the same. I change the division to multiplication, and I'm going to flip this so that it's x squared plus 1 over x squared. And then this is what I'm multiplying together. So I'd get x squared minus 25 times x squared plus 1, and you could have put that on the front or the back, over x squared. And then it stays like that. And then it said, what's the domain of that one? There's two parts, right? This cannot equal 0, which means x cannot equal 0. And this has to be greater than or equal to 0, which means x squared has to be greater than or equal to 25, which means x squared, or x has to be greater than or equal to plus and minus 5, and this is where we test points. Negative 5, positive 5, plug in a point from here, like negative 6. Negative 6 squared would be 36. 36 minus 25 is greater than 0. That works. Plug in a point from here like 0. 0 minus 25 is not greater than or equal to 0. That doesn't work. Plug in a point like from here, like positive 6, and I'd get 36 minus 25, which is greater than 0. This does work. So from this one, because it's greater than or equal to 0, my interval would have been here. And if I take into account this, it says it can't be 0. So if 0 was in the range in which I had taken from the other part, now I'd have another restriction. So let's say that said x could not equal 6. Then I would go from negative infinity to negative 5, like it is. And then I would go from negative 5, or from positive 5. If it was, it can't equal 6, then it'd go from positive 5 to 6, and then 6 to infinity. But because 0 is already ruled out of this, and that's what this says, then this is what my restriction would have been. Does that make sense? Like, let's say the denominator was like x plus 6. Then I would say x, or x minus 6, cannot equal 6. And that would change this by saying, okay, it's okay for it to go from here to here. It's okay from 5 to 6, but it can't be 6, so it's going to get parentheses on 6. And then I can start at 6 again and go to positive infinity. So you have 2 restrictions you have to worry about, the bottom and the square root.
So, since it's not equal to 0,
It was already not equal to 0 by setting it up in the interval that we had. Does that make sense? So that 0 would have been in between those spots. We already ruled it out.